Hello developers, let's start developing. My name is Veko, today is the 1st of January 2025, so Happy New Year! So, we are after the finish of Advent of Code, but we still have some more stars that we need to get. So today we're gonna look at the low-hanging fruit. So we're gonna start with task number 9, this defragmenter. We solved the first part. There should be a link to the video for the first part somewhere around here. We got some solution, and then we need to solve the second part. For the second part, we did make a solution, but that solution didn't give us the correct answer. It did work for the demo input. So if we took the original example input, let's try that. Just hide this. We can run our code and we will get that we have 2858. And moreover, if I actually print out the disk that we get as the result of this, so we have it here, so we can just console.log disk.join on an empty string, which means that we will also get the visual representation, and it's exactly as it should be, basically. But this thing was not working for our big input because it gave us the wrong answer. The answer was way too high. So then I did some debugging on this. So I kinda already did this, so I will just walk through whatever I did. So we already know that we have our disk done kinda correctly. But let's verify that. Let's see what the disk would look like over here once before we start processing it. And then, well, let's console log some slashes or matches or dashes or whatever, and then write out the disk at the end so we can see what our application actually did. Now, if I just start it like this, I will get a wall of text that's not really useful. So what I am gonna do, I'm gonna output this to a file. I will call this file disk.log. And let's see what is happening. So this is one debugging trick that a lot of people do. Kinda don't understand that we can dump the input of of whatever it is we want to do, and then peruse it at our leisure. So this is the first part and this is the result. Let's open a new file. Yeah, we have a single line that's kind of too many characters long, so we might get some issues with pasting. It will eventually work out. So what we can see here is that we have for the input actually an even 10,000 files. Makes sense since the input is 20,000 characters long. So looks like this first part is kinda okay when we have a lot of files. So we have our file, the last one. This is actually 9999. So this file is two things long, which means that it should be over here. And this one is, we can just count the 8s, 1, 2, 3, 4, 5 long, so it should be over here. And then the next file that's one sector long should be over here. Let's see if we have that. Yeah, we have that. And then we have a dot here and a dot here. So it looks like most of the files are actually where they were supposed to be. So this first part of the disk looks like kind of populated, which is what would we expect from the correct answer. But scrolling through this file, I went to the end and I noticed this. As far as I understand defragmenting, we should actually get less congestion at the end of the disk. And this is position of 237,000 and this is position 237,000, which means that we are not writing less characters. But suddenly this means that the file 1122 suddenly moved here. That's weird. So this was my first indication that something weird is happening. So I don't really need the files, so I won't save them, but it seems like we are moving files that we're not supposed to move. We're moving files that are in the middle, we're moving them toward the end. So I said, let's replace this with another example. I had an inkling what happened. That when we are moving the files, we move some files in the opposite direction. So we're not moving them closer to the beginning of the disk, we're actually moving them away from the beginning of the disk, and that actually increases fragmenting. So I started with this example. Basically 5 identical numbers, which means that we have a file of size 3, then an empty of size 3, and another file of size 3, an empty of size 3, and yet another file of size 3. So basically the file number 2 should move to the empty number 0, and that should be it. So we should get 0, 0, 0, 2, 2, 2, 1, 1, 1 in our disk map. Do we get that? Let's see, and now the error is obvious. We actually moved the file 111 because is there an empty that can hold it? Yeah, this empty. This empty is able to hold this file, but is it a good candidate? No, because it's after the file. We don't move the file toward the end of the disk because we want to mash them up at the beginning. So I looked at my code, and basically what we need to say is if the index of the empty is bigger than the index of the file, then don't move it. And actually this is going to be an equality like this, because even if the empty has the same index as the index of the file, don't move it, because the first empty is after the first file. The seventh empty is after the first seventh file, so don't do it. Let's see what happens now with this. And now we're getting what we would expect. So let's get back to the huge input. Yep, the 20,000 digit one. Yeah, that's the one. And let's log it to a file again. So this basically redirects everything that should go to the console into a file, so I can take a look at the file. I will directly go to the end of the file because that's the interesting part. And we should see something like this. A bunch of dots that are empty space at the end of the disk. And then we have some files. As we get closer to the beginning of the disk, we should get more and more and more and more and more data, way less. Oh, now we're not getting anything empty. Oh, I know what happened. Basically, a single length files were moved away from this. Now they're staying, so we have no empty sectors in most of the disk, which is something that we actually wanted to do with the fragmenting. The first one is over here near the end. So this looks like a much better solution. So now instead of this, I will just transfer this into a debug log, which means this will run, but only if I explicitly run the code in a debug mode. But if I start it normally, I will just get the answer, and I got the answer. Note that this answer is bigger than the result for part 1, but it shouldn't be a lot bigger. It should be somewhat bigger, like it's 2% bigger. So let's see if this is the actual correct solution to the puzzle. And it is. So we got our 37th star. And that's great because we are one step closer to finding the chief historian and preparing the catalog for Santa Claus, and everything is nice and fuzzy. I still have some days left until the Orthodox Christmas, when the Orthodox Santa Claus comes along, so I still have some time to do it properly. Anyway, if you like this video, like, subscribe, click the buttons, don't touch the bell button, and keep developing.